This question is IB exam style question for about the circular motion. As you see in the diagram, this is a pole and it is spinning about its axis of rotation. As I'm showing you, this is the imaginary axis of rotation around which it is moving counterclockwise with some angular speed. All right. So when it is spinning about its axis of rotation, this mass which is hanging, which is attached with the two strings of the same length, it is executing in the meanwhile what kind of motion? A horizontal circular motion like this horizontal circular motion. And this circular motion is only possible, is due to the centripetal force. Now, which force is playing the role of centripetal force, which force is pulling this object continuously towards the center, we have to figure it out with the help of free body diagram. So right now you can see there must be the three forces exerted. The one is a tension 1, the one is a tension 2 in this string, and these two will be different magnitude, although the length is same, but the stretchiness in the string is not similar. That's why the magnitude of the tension will be different. And the third force is of course the weight, and I can show you all of this in a free body diagram over here. Okay students, so when I will draw these forces in a free body diagram, this is the object on which the forces are applied, and this is a direction of force which I am showing you from the diagram, and this force must be larger in magnitude. Remember that. Why is that? Because uh, there is a no force, there is a no resultant force in the y direction. The sum of all forces in the y direction is 0. And why I'm saying that? Because this object is only accelerating along x-axis, so which means that ax is not equal to 0 but ay is equal to 0. The forces along vertical axis are balancing, but the forces along x-axis are not balanced with each other. Why? Because you know that it is continuously accelerated towards center, means along x-axis. That's why I'm saying this. So this is a force of tension 1, and whereas the one force is mg, the weight, and the other force is at the in this string is, I'm going to show it with the smaller arrow, let's say like this. Okay students, before we break the vector into its components in the next diagram, I want to show you that what angle is actually made the string with the horizontal, and you can assume this is a right angle triangle, of course it's that. And if we apply the trigonometric ratio, which is sine theta, okay, let's say it's a theta 1, for example, theta 1 is equals to opposite 0.50 over hypotenuse, that is 1. So what is the value of theta 1? So if you take sine inverse of 0.5, so at an angle of 30 degrees we get 0.5. That's why this is an angle 30 degree. Okay, so it means that if this angle is 30 degrees, which means that the other angle, this angle, is also 30 degrees. Now I'm going to show you these angles here and we will make the components. So this is angle 30. So when you will make components, so the one component of this force is exerted towards left, and we can say this is a force of tension 1 cos 30, all right, because it is adjacent with theta. Okay, in the same manner we have another force, tension force x component, that is also directed towards the center. Okay, don't forget that it is directed towards center, and now we can say ft2 cos 30 degrees. And that's why I'm going to erase this, because we have resolved it into its components. What about their y components? So if I draw the y component, so this is a ft1 sine 30 degrees. which must be obviously more than the weight. Why? Because if you draw the second vector component downward, that is ft2 sine 30, so you see that in the vertical downward, the two forces are combined with each other because they are in the same direction, and they are equal to this force which is directed upward. That's why I was telling you that there is a no resultant force along y-axis, because forces are balanced. Okay, dear students, so that's why now we can draw the situation more clearly, in which I can show you now that this is a mass which is attached with the two strings, and on this mass there are two forces, component of forces. You see that the two forces components which are exerted towards the center of the circle, and together these two forces, I can call them, these two are, sum of these two forces is equal to centripetal force. So while making this equation, you may write the negative sign because these two components of forces are directed towards left. But eventually, if you take the negative sign common, or if you multiply with -1 on both sides, it will become positive eventually. So for simplicity, I'm writing it like this. I hope you understand that the sum of these two forces, component of forces, is equals to mv square over r. That was the concept that we had learned. Okay, now, so we have the mass and we also have the speed. All right, mass, we can put the value, because in this question we have to find out the tension in each string, which means we have the two unknowns, and that's why we need two equations. Okay, so if you plug the value, you will get first equation. Cos 30 is 0.86, and if we multiply 0.250 times speed is 8, so 8 square, which is 64, divided by radius is unknown. Okay, let's quickly find the radius. Do you see this triangle? Okay, I draw this again. In this triangle, this is the radius of our horizontal circle. Okay, and we luckily we know already the values of the two sides. Okay, so if you know the values of two sides, you can apply Pythagoras principle to find out the adjacent side. Okay, which is the hypotenuse square is equals to opposite square plus the adjacent, which is our radius. Okay, this is the radius, so radius square. So from here you can find out its value. Okay, so the radius is 0.87 approximately. Okay, this is the radius, whereas the cos 30 is also approximately 0.87, so I can write it. And you see here the 0.87, this is 18.39. So let's write 18.39, whereas if I take 0.87 out of this bracket, so we can make a simple equation, and then we can divide this on the other side of the equation. Okay, students, so we got 21.13. So this is our first equation. All right, so you remember I told you in this question we have two unknowns, that's why we need two equations. So first equation we got by assuming the forces along x-axis. Now it's time to go back into the diagram, in which we made components. This one, you have seen that this is the only component of the force that is directed along the positive y-axis, but there are two forces which are directed vertically downward. The one is a component of force and other one is the weight, and together these forces are balanced with each other. So I can make another equation that ft1 sine 30 degrees is must be equals to the ft2 sine 30 degree plus mg. All right, so sine 30 is 0.5, so 0.5 force of tension 1 is equals to 0.5 force of tension 2 plus 0.250 times 9.8. So you can see we are proceeding to get another equation. I am going to take it on the other side. Okay, and now we can take 0.50 out of this bracket, and inside we get another a simple equation which we can solve later with the equation 1. And if you take zero point 0.5 on the other side. Okay students, so we have got the two simultaneous equations. So onward is very simple task. What you need to do, you can add these two equations. This one and this one will be cancelled out, and you can solve them for the force of tension 1, or you can also apply the substitution method to solve these two equations. Anyways, what we will get, we will get the force of tension if we add these two equations. So then we will get 22.35, and then later we can solve it. So this is the force of tension in the string 1, that is 11.18. You remember I told you that this force of tension must be larger than the force of tension 2. Let's verify this fact. So if you can plug this value in any one of these two equations. So finally we got it. This is 9.95 Newton. It means that it is less stretched than the string 1. Okay, and it is also like the string 1 is also stretched more because of the contribution of weight. Okay, so this is all the question, and I hope you understand this question.